Hello, Assalamualaikum. My name is Iza Atira binti Ahmad Sirfan.
My name is Nur Shafia binti Waka. My student ID is 209258982.
My name is Muhammad Shafiqul Hamri bin Amran.
And we are from Group 7. In this video, we're going to conduct straight beam experiments. So let's... Firstly, mark the test specimen with 900mm by using a steel ruler. Label support A and B. Mark the distance of 100mm, 200mm, 300mm and 450mm from support A. Loosen the suspender and install it at wake support A and B. Tighten up the suspender screw. Put the wake scale and hang up the specimen. Loosen the screw off rider and install it on the test specimen. Move the reader of wake to the distance of 100mm from support A. Reset the wake scale value to 0. Put the wake of 50 N on the wake hanger and hang up at the rider of wake. Read the wake scale reading for both supports and record it in table 1. Repeat steps 2 to act for the difference distance X. For the reaction force, there is no much difference with the standard value and the calculation for each test specimen. The error is less than 10% but still not accurate enough. Possible errors are maybe because of the apparatus on the horizontal surface is not balanced enough and the observation and calculation using the wrong method. Bending can induce both a normal stress and transverse shear stress. By applying the load to the free end of the beams, will cause them to bend and slide past each other. The position of the beam will change its bend and shear stress. Yes, steel is stronger than brass because brass is easy to form into various shapes. So brass also can easily be bent through the experiment. Yes, there is a difference. The top of the beam will compress while at the bottom is in tension. At the transition between the compressed and tensile region, the stress becomes a zero, which is the natural axis of the beam. Cantilever beam is a beam whose end is fixed and the other end is free. simply supported beam is one whose ends freely rest on walls or columns or knife edges. Continuous beam has more than two supports. Overhanging beam is one in which the support are not situated at the ends. Fixed beam is one whose both ends are rigidly fixed or built into supporting walls or columns. In conclusion, to determine the reaction force, maximum shear stress, and maximum bending stress in a straight beam from a bending test of test specimen is achieved. There are two types of specimen used, such as brass and steel. From this test, we can determine the difference between the results and the percent error. Thus, to compare the experimental reaction force with the theoretical value for the loading on the load beam is also accomplished.
The reaction force for both specimens are the same, while the shear force and the bending moment are different. The value shear force for steel bar is larger than the value for shear force for brass bar. Meanwhile, the value of bending moment of brass bar is larger than the value of bending moment for steel bar. The possible sources of errors are systematic error, occur during reading the value from the dynamometer, linear caliper, and steel ruler, or putting the suspender too tight. The load is located near the edge of the specimen. The bending and shearing stress will be more difficult to find the result because it will need more forces. When the load is located on the middle of the specimen, it will be easier to find the bending and the shearing stress because less force needed to be applied. Yes, steel will be stronger than brass because based on the result of the maximum bending and shear stress value of the steel is higher than brass. If the value for both stress are high, that means steel needs a lot of force to be applied to get a result on the bending of the steel. No, there will be no difference because the bottom area of the specimen and the top area of the specimen will be the same. When the force is acting on the top of the beam, it will have the same stress value when the force is acting on the bottom of the beam. These are the classification of beam: simply supported beam, continuous beam, overhanging beam, beam fixed at one end and simply supported at the other end, cantilever beam, fixed beam. Overall, all the objective to regulate reaction force, maximum bending stress, and maximum shear stress in the straight beam from a bending test for tested specimen, and to differentiate the experimental reaction force with the theoretical values for a loading on the straight beam were both achieved. The first objective was achieved by getting the value from the dynamometer and use the value to find the maximum bending stress and maximum shearing stress. The second objective can be obtained by calculate both value from experimental and calculation.